Good morning. Myself Sadiswaran, Assistant Professor, Department of Medical Electronics, SRM Alima Engineering College. I am going to handle the subject Signals and System. The topic Classification of Signals. Before going into the topic, we have to know what is base signal. Signal is a physical quantity which varies with time, space, or any other independent variable. Example for a signal: traffic signal, ECG signal, EEG signal, power supply. These are the some of the examples of signals. The signal may be one-dimensional signal, two-dimensional signal, multi-dimensional signals. Elementary continuous time signals. Some of the signals are used as a input for studying systems behavior. This includes step, impulse, ramp, sinusoidal and exponential signals. First one, unit step signal. It is represented by u of t. U of t equal to 1 for t greater than or equal to 0, 0 for t less than 0. If you look at the waveform, t greater than 0, the value is 1. For t less than 0, the value is 0. This is a unit step signal. There is a continuous time representation is u of t, and discrete time representation u of n. U of n equal to 1 for n greater than or equal to 0, 0 for n less than 0. This is u of n with respect to n. It is 1 for t greater than n greater than 0 and 0 for n less than 0. This is a unit step signal. Next signal is unit impulse signal. It is represented by the letter del of t with respect to t. This is for continuous. In terms of discrete, u of n with respect to n. Here integral minus n to plus infinity del of t dt equal to 1 for t equal to 0. Del of t equal to 0 for t not equal to 0. This is a unit impulse signal. Similarly, in case of dt signal, discrete time signal, del of n equal to 1 for n greater than or equal to 0, 0 for n less than 0. At time t equal to 0, value is 1, for all other value is 0. This is a unit impulse signal. The next signal is a unit ramp signal represented by the letter r of t with respect to t for continuous, for discrete r of n with respect to n. R of t equal to t for t greater than or equal to 0, 0 for t less than 0. If you substitute t equal to 1, you will get 1. Substitute t equal to 2, you will be getting 2. If you substitute t equal to 3, you will be getting value 3. So, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, it goes on. It looks like a ramp. It is called as a unit ramp. Then next one is a represented by r of n. This in case of discrete, r of n with respect to n. Similarly here, if you substitute n equal to 0, r of 0 equal to 0, r of 1 equal to 1, r of 2 equal to 2, r of 3 equal to 3, it goes on. So 0, 1, 1, 2, 2, 3, 3, 4, 4, it goes on. This is a unit ramp signal. The next signal is a continuous time and discrete time real exponential signal. X of t equal to b e power minus at. This is a decaying signal. If a is less than 0, which means that it is a decaying exponential. If r equal to 0 to 1, this is also a decaying exponential. But when a greater than 0, it is a rising exponential. The signal rises. Here in the case of here, signal is a decaying exponential. This is increasing or a growing exponential. Next one, sinusoidal signal. It is represented as x of t equal to a sin omega naught t plus pi or theta. Here a represents the amplitude of the signal, omega naught represents the frequency of the signal, t is the time of the signal, and pi represents the phase shift of the signal. To find a period, using t equal to 2 pi by omega. This is for continuous time. For discrete time, x of n equal to a cos or a sin omega naught n plus pi. Next signal is a rectangular signal. It is represented as RECT of t. Rect of t equal to 1 for minus 1 by 2 less than t less than 1. For the period minus 1 by 2 to plus 1 by 2, the value is 1. This is called as a rectangular signal. The second one, rect of t by t equal to 1 for minus t by 2 less than t less than t by 2, 0 elsewhere. This is a rectangular pulse. Next one, triangular pulse, x of t equal to 2a by t plus t by 2, or 2a by t minus t by 2. This is for minus t by 2 to 0 and 0 to t by 2. This is a triangular pulse. Similarly, the signum function represented as sgn of t equal to 1 for t greater than 0, minus 1 for t less than 0. For t greater than 0, the value is 1. For t less than 0, the value is 0. This is represented as signum signal, sgn of t. Next one, sin c pulse, or you can say sin c equal to sin theta by theta. Here sin pi x by pi x. This is a sin c pulse. Next one, relation between the signals. First, this is a, we know that this is a ramp signal because it looks like a ramp. If you differentiate the ramp signal, you will be getting step signal. Similarly, if you differentiate the step signal, you will be getting the del of t. It's an impulse signal. Similarly, here, if you integrate the this is a differentiation, opposite is a integration. Similarly, here this is a impulse signal. If you differentiate the signal, you will be getting a step signal. Again, if you integrate the step signal, you will be getting the ramp signal. There is a relationship between these signals. Classification of signal. There are 5 classification of signal: CT signal and DT signal, deterministic and random signal, periodic and aperiodic signal, symmetric and asymmetric signal, energy and power signals. These are the 5 classification of signal. First one, CT signal and DT signal. CT, continuous time signal. DT, discrete time signal. Continuous time signal is defined for all instant of a time, or we can say it is defined for every instant of a time, is a continuous time signal. Example, a temperature recorded over a period of a time, say 0 to 24 hours. I am continuously recording 24-hour temperature of a human. It is considered as an example for a continuous time signal. In a case of discrete time signal, it is defined for discrete instant of a time. We can say how it's a discrete instant of a time means we are not going to record a temperature continuously. We are going to take every record the temperature every 6 hours or every 8 hours or every 3 hours. This can say we can call this discrete time signal. For example, considering that I am going to record a temperature every 6-hour interval, starting with 0, 6 a.m., then 12 noon, then again 6 p.m., then again 12 a.m. Okay, continuously I am recording 4 times the temperature every 6 hours, which means that if you want to define a signal at 5th hour or 5 a.m. or 3 p.m., we don't have, we cannot say what is the temperature because it is not recorded, it is not defined. We cannot say it is a 0 because temperature of the human never become a 0. So during this time, consider this is 0 hour, 6 hour, 12 hour, then again 6, again 12. So which means that if you want to know the temperature of 3 a.m., it is not defined. We cannot say it is a 0. That is known as a discrete time signal. Next one, deterministic and random signal. If any signal which can be represented by a mathematical equation like a sine wave. A sine wave, it can be represented as x of t equal to a sin omega naught t plus theta, or cos theta x of t equal to a cos omega naught t plus pi, like that. If any signal which can be represented by a mathematical equation, the signal is said to be a deterministic signal. If any signal which cannot be represented by the mathematical equation, the signal is said to be a random signal. Example for deterministic signal, sine wave, cosine wave, etc. For a random signal, because a random signal means which cannot be represented by the mathematical equation, say noise generated from amplifier, filter, these are the examples of a random signal. The next signal is a periodic and aperiodic signal. As by periodic signal, a same set of signal repeat over a period of a time, it can be called as a periodic signal. They consider this is sine wave, this is one cycle, sine wave of one cycle, then again the cycle repeats, it can be called as a periodic signal. This example for a periodic signal is a sine wave. Condition for periodicity, x of t equal to x of t plus t naught. CT signal repeat after t naught. This is a CT signal. There is a repeat after the T naught. It is a periodic. If it does not repeat after a T naught, it is a aperiodic signal. This is a continuous time periodic signal is represented by letter x of t. Discrete time periodic signal can be represented by the letter x of t equal to x of n plus capital N. Here same set, same cycle repeats, but here the set of signal does not repeat over a period of a time. It can be called as a non-periodic signal or aperiodic signals. The next signal is a symmetric even and asymmetric odd. We can say even and odd signal, or we can also say symmetric and asymmetric signal. What is symmetric, asymmetric? Here condition for signal to be symmetric or even, x of t equal to x of minus t, x of n equal to x of minus n. If you look at this, this is a one side, this is another side. If you fold the signal, both will exactly match. We can exactly divide the two signal. This can be called as a cosine signal. It's an example for a symmetric signal or even signal. Then next one, condition for odd signal, x of t equal to minus x of minus t and x of n equal to minus x of minus n. Example, sine of minus theta equal to minus sine theta. For example, if you want to separate the two signal, if you fold, it does not exactly matches with the signal. If you fold the signal and multiply by minus, again it exactly matches with the left side of the signal. So this can be called as a asymmetric or odd signal. We can separate the two signal. Even part, to find the even part of the signal, formula is xe of t equal to 1 by 2 x of t plus x of minus t. For odd part, x1 odd of t equal to 1 by 2 x of t minus x of minus t. Here plus x of minus t means even signal, minus x of minus t, which means that odd part of a signal. This is for a continuous time. For a discrete time, xe of n equal to 1 by 2 x of n plus x of minus n. For odd part, xo of n equal to 1 by 2 x of n minus x of minus n. So another one, if both the signals are not satisfied, the signal is a neither even nor odd, or we can say neither symmetric nor asymmetric signal. Next one, energy and power signal. Definition of energy: a signal is said to be energy signal if normalized energy is non-zero and finite. That means that energy signal should be finite. 0 less than E less than infinity and power equal to 0. The signal is said to be a energy signal. Example: all periodic signals are power signal. All most of the aperiodic signals are energy signal. Most of the periodic signals are power signal. To find the energy and power, the formula is E equal to integral minus into plus infinity modulus x of t whole square dt for CT signal. For DT signal, E equal to summation n equal to minus infinity to plus infinity modulus x of n whole square for DT signal. In a case of power, power is said to be signal is said to be power signal if its normalized power is non-zero and finite. For a power signal, 0 less than p less than infinity and E equal to infinity. The signal is a power signal. Then classification of signals. Here comparing energy signal and power signal. Power should be finite, 0 less than p less than infinity. Here energy should be finite, 0 less than E less than infinity. This is a formula to find power. This is a formula to find energy. Formula to find power: limit t tends to infinity 1 by t integral minus t by 2 to plus n by 2 x square of t dt. In a case of discrete time, limit n tends to infinity 1 by 2n plus 1 summation n equal to minus n to n modulus x of n whole square. This is for finding power. To find the energy, E equal to integral minus into plus infinity modulus x of t whole square dt. Similarly here for n equal to minus into plus infinity modulus x of n whole square. Most of the periodic signals are power signal. Here most of the aperiodic or non-periodic signals are energy signal. This is an example. This is a sine wave is a power signal. This is a periodic signal. Periodic signals are power signal. Here aperiodic signal example, a rectangular signal. Problems. Now we can going to see the problems on periodic and aperiodic signal. First one, solve whether the following signal is a periodic. If periodic, determine the fundamental time period. If it is a aperiodic, you need not find a fundamental time period. First sum, x of t equal to e power j 2 pi by 3t plus e power j 3 pi by 4t. So the signal is divided into two signals. So we are having two fundamental time period. The formula to calculate the time period for discrete time signal n1, I am using n1 and n2 because the given signal has a two components. So n1 equal to 2 pi by omega m, n2 equal to 2 pi by omega 2 into m. Omega represents the frequency, which is a multiples of t. So 2 pi by 3, 3 pi by 4. So here 2 pi by omega into m. As this is a continuous, sorry, this is n. Okay, a equal to, that is x of n equal to e power j 2 pi by 3n plus e power j 3 pi by 4n. n1 equal to 2 pi by omega 1 into m, n2 equal to 2 pi by omega 2 into m. M is represent the frequency, omega represents the frequency. To find the frequency, multiples of n, which is nothing but a frequency. So here 2 pi by 3 is a frequency 1, 3 pi by 4 is a frequency 2. Omega 1 is 2 pi by 3, omega 2 is 3 pi by 4. So substituting here, simplifying, you will be getting here 3, n equal to 3, m equal to 1. This m represents the smallest integer to convert the time period as a integer. So here 2 pi cancel, you will be getting 1 by 3. If you substitute the smallest integer as 3, you will be getting 1. So n1 equal to 3, m equal to 1. Similarly here 2 pi by 3 pi by 4, it goes 8 by 3 into m. As I already told, m is the smallest integer to convert n into the integer. Even if you put 6, it will become an integer. 9 also it will become integer, but smallest integer is 3. So if you substitute 3, it will be n2 equal to 8 and m equal to 3. To check whether the given signal is a periodic or not, you have to find the ratio of n1 by n2. So here n1 equal to 3, n2 equal to 8. If you look at the numerator or denominator, there is no multiples of pi. So automatically consider the signal as a periodic signal. To find a time period, either you can cross multiply 8 n1 or 3 n2. Now I am using 8 into n1 to find a fundamental period. So n1 equal to 3, 8 into 3 equal to 24. So the given, how I am taking decision, this as a periodic. The ratio, in the ratio of n1 by n2, there is no multiples of a pi. So which means that this is an integer in numerator as well as the denominator, which means that the given signal is a periodic signal with the fundamental time period n equal to 24. We can look at the another signal. X of t equal to 3 cos 4t plus 2 sin pi t. Even if you look at the signal, we can take a decision as a, this is a aperiodic signal. How you can find the given signal is a aperiodic signal? If you look at the frequency of the first one is 4, frequency of the second one is pi. When you divide, take the ratio of t1 by t2, surely there will be multiples of pi in a denominator or numerator. So we can consider the signal as a aperiodic signal. Next one, again consider that this is a integer. This also consider this as a 8. If in both the cases consider 4 and 8, we can say the signal is a periodic signal. Similarly, if you have multiples of pi in both the signal, again we can consider this as a periodic signal. But if you are having any one signal, there is a multiples of a pi, we can conclude that signal is a aperiodic signal. In this case, the first one 2 pi by 4, second one 2 pi by pi, you will be getting pi by 2 divided by 2, ratio of t1 by t2, pi by 2 equal to pi by 4. If you look at the in the ratio, there is a multiples of pi in the numerator. So that is a given signal is a aperiodic signal. If a signal is a aperiodic signal, you need not find a fundamental time period. One more example, x of t equal to 2 cos 10t plus 1 minus sin 4t plus 1. we are having a two components. So we have to find two frequency, time period t1 equal to 2 pi by omega 1. This is for continuous time. T2 equal to 2 pi by omega 2. In a case of discrete, n equal to 2 pi by omega into m. That is a discrete. But for a continuous, t equal to 2 pi by omega. So 2 pi by omega 1 is 10. We will be getting pi by 5. Second signal 2 pi by omega 2. Omega 2 multiples of pi is 4. If you substitute 4, you will be getting pi by 2. If you find the ratio, pi by 5 divided by pi by 2, you will be getting 2 by 5. In the numerator or denominator, there is no multiples of a pi, so we can consider the signal as a periodic signal. If a signal is a periodic, we have to find a fundamental time period. To find a fundamental time period, either we can choose 5 into t1 or 2 into t2. Now I am considering t equal to 5 t1. t1 is pi by 5. Cancel 5, 5, you will be getting pi second. So the given signal is a periodic with the fundamental time period t equal to pi second. So how we can conclude the given signal is a periodic? We have to find the ratio of t1 and t2. In the ratio of t1 and t2, if there is no multiples of a pi, the given signal is a periodic. If suppose we consider that pi in either numerator or denominator, that can be considered as a aperiodic signal. One more example, y of t equal to 20 cos 10 pi t plus pi by 6. This is not a two signal, this is only one signal. Multiples of pi, you are having only 10 pi. This pi by 6 represent a pace, so we need not find t2, only we can find a t1. T equal to 2 pi by omega, omega is 10 pi, cancel pi pi, you will be getting 1 by 5 seconds. So it's a fundamental time period. Only it's a when the signal is a periodic, you have to find a fundamental time period. Next, another example, x of t equal to 3 cos 17 pi t plus pi by 3 plus 2 sin 19 pi t minus pi by 3. I already told the multiples of t is nothing but frequency. In that you are having two frequencies. First frequency 17 pi, second frequency 19 pi. So to find t1, 2 pi by omega 1, 2 pi by 17, we will be getting 2 by 17. Similarly, t2, 2 pi by omega 2 is 19 pi. Cancel pi pi, you will be getting 2 by 19. Next, we have to find the ratio of t1 by t2. Ratio of t1, 2 by 17. Ratio of t2, 2 by 19. See, after simplification, we will be getting 19 by 17. Here, there is no multiples of pi in either numerator or denominator. The signal is a periodic. Signal is periodic, we have to find a fundamental time period. As I already told, either you multiply 17 into t1 or 19 into t2. I am using t equal to 17 t1. Substitute the t1 value 2 by 17. Cancel 17, 17 will be getting 2 seconds. So the fundamental time period is t equal to 2 seconds. One more example, x of t equal to 3 cos 60 pi t plus 2 sin 50 pi t. You are having multiples of t 2. So you are having two frequencies. One frequency 60 pi, another frequency 60 pi. To find t1 equal to 2 pi by omega 1, t2 equal to 2 pi by omega 2. Substitute here, cancelling 1 by 35, 1 by 25. You have to find ratio of t1 by t2, 1 by 30 divided by 1 by 25. It will, after simplification, it will be getting 25 by 30. Cancelling with 5, 5 by 6. I already told to find a fundamental time period, either you can use 6 into t1 or 5 into t2. Here I am using t equal to 5 into t1. t1 value is 1 by 30. Cancelling, you will be getting 1 by 16 second. The given signal is a periodic with the fundamental time period t equal to 1 by 6 second. Next, we are going to see problems on odd and even signal. Derive the odd and even components of the signal. X of t equal to sin t plus 2 sin t plus 2 sin square t cos t. This is given. How to find the even component? We know that formula x of t equal to x of t plus x of minus t by 2. So we need to find x of minus t. Substitute instead of t, we have to substitute minus t for all. So if you substitute here minus t, sin of, we know that sin of minus theta minus sin theta, so it will become minus sin t. Similarly here, if you substitute minus t, sin of minus theta minus sin theta minus 2 sin t. Here if you substitute minus t, sin of minus theta become minus sin theta, cos of minus theta become plus cos theta. So minus minus, it will become plus. So 2 sin square cos t. Now to find the even component of the signal, add the 2 divided by 2. you will be getting, if you add these two, cancelling these two, so you will be getting 4 sin square t cos t divided by 2, you will be getting 2 sin square t cos t. This is a even component signal. To find the odd components of the signal, x of t minus x of minus t by 2. Considering this minus plus plus, this will become minus. We cancel this, you will be getting 2 sin t plus 4 sin t divided by 2 equal to sin t plus 2 sin t. This is an odd component of the signal. Next one, problems on power and RMS. What is the power and RMS value of the signal? X of t equal to a cos omega naught t plus theta. This is a given problem. We know that to find a power, P equal to limit t tends to infinity 1 by 2t integral minus t2 plus t modulus x of t whole square dt. It's a formula to find the power. Given that x of t equal to a cos omega naught t plus theta, substituting here a cos omega naught t plus theta whole square dt, taking a whole square outside, you will be getting a square by 2t cos square omega naught t plus theta into dt. We know that cos square theta formula 1 plus cos 2 theta divided by 2. Substitute here. Then separating the two integrals, so it will become minus t to t dt plus integral minus t to t. This will become 0. So, we will be getting dt. Integration of dt, it will become t. Substitute minus t to plus t. Substitute the upper limit minus lower limit. That is t minus of minus t. This will become 2t. Cancelling 2t with 4t, we will be getting a square divided by 2. This is a power. We know that RMS, root mean square value, it is nothing but root of power, root of a square by 2. So, taking a out of root, it will become a, and 2 with root by 2. So, finally, RMS value is 4 divided by root 2, or root 2 we can write it as 1.414. One more examples of on power and RMS. X of t equal to cos t. If you substitute cos t, this will become cos square t. Cos square theta 1 plus cos 2 theta divided by 2. Separate the integral 1 by 2 cos 2t divided by t. Anyhow, this will become 0. Again, after simplification, again you will be getting power equal to 1 by 2. Unit of power watt. RMS, taking root of power 1 by root 2. One more examples. Estimate the energy and power of the given signal x of n equal to cos pi n. Instead of theta, we are having pi n. This is a discrete. So, substituting the discrete energy and discrete power, E equal to limit n tends to infinity, summation n equal to minus n to n, modulus x of n whole square. This is a formula to find energy. And formula to find power, P equal to limit n tends to infinity 1 by 2n plus 1, summation n equal to minus n to n cos square pi n. Now, similarly here, cos square theta represents 1 plus cos 2 theta by 2. So, 2 by 4. Cancelling after simplification, it will become pi n divided by 2 divided by 2. Again, separate the two integral 1 by 2 and cos n pi by 2. You are having n tends to infinity. If you substitute n equal to infinity, infinity plus anything, it will become infinity. So, the value is infinity. Now, to find the power, formula is the limit n tends to infinity 1 by 2n plus 1, summation n equal to minus n to n, cos square pi n divided by 4 equal to 1 by 2 limit n tends to infinity 1 by 2n plus 1. We know that formula cos square theta 1 plus cos 2 theta whole divided by 2. The whole divided by 2 is taken outside. Then after simplification, this will become 1 plus 2n. Cancelling this, will be getting value as 1 by 2. Energy is infinity, power equal to 1 by 2. So, here power is finite, energy is infinite. We can conclude this as a power signal. Next, examine whether the following signals are energy signal or power signal. The same, you have to calculate the energy and power. Substituting 1 by 3 power n u of n. We know that u of n means 1 for 0 to infinity. So, change the limit as minus n to n to 0 to n, and substitute here 1 by 3 power n whole square 1 by 3 power 2n. Then whole square is considered as 1 by n power n. We know that summation n equal to 0 to n, a power n equal to 1 divided by 1 minus a. So, after simplification, it will become 9 by 8. Energy is finite. Similar, I am finding power. Power formula limit n tends to infinity 1 by 2n plus 1, summation n equal to minus n to n modulus x of n whole square. Similarly here, substituting the value 1 by 3 power whole square 1 by n power n for power 1 by 2n plus 1. We know that the formula summation n equal to 0 to n a power n equal to 1 minus a power n plus 1 divided by 1 minus a. Substitute here, the value becomes 0. So here energy is finite, power 0. We can put the energy the signal as a energy signal. One more problems on energy and power signal. X of t equal to t into u of t is a formula to find energy and formula to find power. Substituting t square u of t. U of t, we know that 1 for 0 to infinity. Change the limit minus t to t to 0 to t because given as u of t. U of t equal to 1 for t greater than 0. So t square modulus t square dt become t square. Integrate this equation, t cube divided by 3. Substitute the limit 0 to t. So value is t cube divided by 3. It will become infinity. Capital T, 0 to capital T. Substitute capital T cube divided by 3. You have to substitute t equal to infinity. If you substitute infinity, the value is 0, e equal to infinity. Next, to find a power, p equal to limit t tends to infinity 1 by 2t minus t to t modulus x of t whole square dt. Now substitute here, change the limit as 0 to t because of given as u of t. So t square, again you will be getting t cube divided by 3. Cancelling t and t, it will become 1 by 6 t square. If we substitute t equal to infinity, again this will become infinity. As I earlier told, energy is finite, power equal to 0, energy signal. Power is finite, energy infinity, power signal. If both are not satisfied, the given signal is a neither energy nor power signal. One more problems. X of t equal to 1 plus e power minus 5t. Substitute here. This will become a plus b whole square, a square plus b square plus 2ab. Integrate this equation. Substituting the upper limit capital T and lower limit minus t. We substitute t equal to infinity because we are having t 2t. If you substitute infinity plus anything, infinity. Similar to find the power, p equal to limit t tends to infinity 1 by 2t minus t to t. Again modulus x of t whole square et. Expand this equation, a square plus b square plus 2ab. Integrate this equation, substituting the upper limit, lower limit. You will be getting cancelling, you will be getting 1. Here power is 1 watt, energy is infinite. Power is finite, energy is infinite. The given signal is a power signal. Next, we are going to see the operation on signals. There are mainly 5 operations, but time shifting, time reversal or time folding, time scaling, amplitude scaling, signal addition and signal multiplication. These are the operation of signal. This is the first one, time shifting. Time shifting may advance or delay the signal by some unit. Here consider that this is a u of t. U of t equal to 1 for t greater than 0, 0 for t less than 0. This is a standard signal. Next one, I am going to find u of t minus 2, which means that delay the signal by 2 unit. Here the signal is starting 0. If you delay by 1 unit, the signal should start at 1. If you delay the signal by 2 unit, the signal should start at 2. So 2 unit delay, this can be u of t minus 2 means 2 unit delay of the original signal. Next one, u of t plus 2, advance the signal by 2 unit. The signal starts with 0. If you advance the signal by 1 unit, it should start with minus 1. If you advance the signal with the 2 unit, it should start with minus 2. This is for a continuous time. This is for a discrete time. This is a discrete u of n. From the u of n, delay the signal by 2 unit, starts with the 2. Advance the signal by 2 unit, starts with minus 1. So this is a time shifting. It may advance or delay the signal by some units. Time reversal, or we can say folding. This is the original signal. Folding, if you fold the signal, what will it means? Plus side signal goes to minus side and minus side signal goes to plus sides. So here left side signal is 0, the right side signal is 1. If you fold the signal, left side become 1 and right side becomes 0. This is a folding signals. Folding step signal because the given input is a step signal. The step signal is folded, it will become u of minus t. Similarly, is a unit step discrete time signal. Again, if a time reverses, plus 1, okay, the signal present in the 1, it goes to minus 1. The signal present in the 2 goes to minus 2, which means that folding u of minus n, multiplying the time axis by minus. If you are having plus 1, if you multiply the time axis by minus, this will become minus 1. Similarly, plus 2 goes to minus 2, plus 3 goes to minus 2, plus 3 goes to minus 3, plus 4 goes to minus 4. It goes on. This is known as a time reversal, or it can be called as time folding. The next signal is a time scaling signal. We are going to scale the time axis. Here, if you look at the signal, what the use of time scaling? The time scaling may compress or expand the signal. For this is the original signal. I want to compress the signal y of t equal to x of 2t. Okay, how to find means how to, this should be converted to x of t. If you substitute t equal to t by 2, this will become x of t. So divide the time axis divided by 2. If you divide the time axis by 2, this will become minus 1. If you divide the time axis by 0, 0. If you divide the time axis by 1, 1 by 2. If you divide the time axis by 2, 1. So the signal compresses. Suppose if given that y of t equal to x of t by 2. How to find t, how to convert this into t? Multiply with the 2t, cancelling 2 to 2, this will become x of t. So multiply the axis by 2, multiply the time axis by 2. So minus 2 into 2, minus 4, minus 2, 0, 2, 4. So what the use of a time scaling is? The time scaling may compress or expand the signal in along the time axis. This is an example for continuous time, this is an example for a discrete time. If you look at here, this is the original signal. So another signal is given. 0 for 1.5, for 2, 1, for 3, 1.5, for 4, 2. I want to find y of n equal to x of 2n. I already told, divide the signal by, if you put n equal to n by 2, this will become x of n. So divide the time axis by 2. If you divide the time axis by 2, this will become 0.5. In a discrete case, we should not take the point. We should take only the integer. So 0th axis is 0 for 2. If you divide by 2, this will become 1. For 1, 1. Similarly, for if you divide by 2, 1.5, it need not be considered. If you divide the 4 by 2, it will become 2. So for 2, it become 2. This is a compression of the signal. Next one, to expand the signal. Another one, how to find expansion into 2. Okay, given that x of n divided by 2, if you put n equal the n 2n, 2 cancel, this will become x of n. So multiply the time axis by 2. This is a given signal, multiply the time axis by 2. So 0, 2, 4, 6 and 8. So for 2 only 0 0.4, for 4 1. The remaining thing it is considered as a 0. The time scaling. Next one, amplitude scaling. In the previous one, the time scaling may compress or expand the signal along x-axis. Here amplitude scaling goes along the y-axis. This is a given u of t signal. I want to find y of t equal to 2 times of u of t. So you are having the amplitude in a given as 1. If you multiply the amplitude by 2, it will become 2. So y of t equal to 2 times of u of t. So multiply the amplitude by 2, it will become 2. Similarly, y of t equal to minus 2 u of t. This is a u of t. Multiply this by minus 2. 1 into minus 2. This will become minus 2. So it goes on negative axis. So similarly, this is a u of n. In the u of n, you want to write 2 u of n. Multiply with the 2. This amplitude become 2. Similarly, if you multiply the u of n by minus 2, this will become a negative signal. This is the amplitude scaling. Time scaling may compress or expand along x-axis. This is along y-axis. Next one, problems on operation of signal. A discrete time signal x of n is shown below. This is a given signal. Plot the following signal. First one x of n minus 2. Second one x of n plus 1. Third one x of minus n. Fourth one x of minus n plus 1. fifth one x of 2n, sixth one minus 2n plus 1. First one, I already told this is a given signal. How to find x of n minus 2? What is n? What is x of n? Given signal. What is x of n minus 2? Delay the signal by 2 units. Here the signal starts with minus 1. So 2 unit delay, the signal should start with 1. So shifting every signal by 2 unit. So this will become the answer for x of n minus 2. Just shifting from one shift means minus 1 to 0, second shift 0 to 1. So the signal here starts 0, 1 and it goes on. So this is x of minus 2. Second one, x of n plus 1. What is x of n plus 1? Plus 1 denotes advance. Here advanced by 1 unit. This is a given waveform. In the waveform, advance the signal by 1 unit. The signal starts at 1. Here one shift advance, this will start with minus 2. So this is a x of n plus 1, advance the signal by 1 unit. Next, third one, x of minus n. I already told this is nothing but time folding or time reversal. So whatever the signal present in the positive side, it goes on negative side. Whatever the signal present on the positive side, it goes on negative side. For example, here minus 1, 0. This minus 1, it goes to plus 1 side, 0, 0, 0, one side. Okay, similarly, sorry, third one x of minus, this is x of minus 1, 0, 0, 0. The signal present in the plus 1 goes to minus 1. So minus 1 equal to 1. The signal present in the plus 2 goes to minus side. So minus 2 equal to 2. The signal present in the at 3, it goes to minus 3. Signal present in the 4 goes to minus 4. Signal present in the 5, it goes to minus 5. This is nothing but time reversal or time folding. Then x of minus n plus 1. It is nothing, it is a time delay, not advance. Because if you look at this x of n plus 1, it is the signal advanced by 1 unit. Because if you consider that n, it is a positive n. But if you look at here negative n, if n is positive, you are having plus 1, it is advance. If n is negative, you are plus 1, it is delay by 1 unit. So just delay the signal n minus n delayed by 1 unit. This will become x of minus n plus 1. Then fourth one, x of 2n. I already told how to find here. So substitute n equal to n by 2, 2 cancel. So divide the time axis by 2. So if you divide the time axis by 2, 0 becomes 0, 1 become 1 by 2. This would be, this need not consider. 2 become 1. So 1 equal to 2. 3 need not consider because 1.5. 4 divided by 2, it becomes 2. For 2 equal to 2. The last one 5, it is 0.5. We need not consider this. Okay, similarly the next one, x of minus 2n plus 1. X of minus 2n plus 1. First we have to find x of minus 2n. This is x of plus 2n. Okay, if you reverse this, it plus side signal goes to minus side and minus side signal goes to plus side. Then you are having negative n. So if plus means delay by 1 unit. So after it goes here 1, it starts with here. This is x of minus n plus 1. One more example. This is a CT signal x of n is shown in figure below. Sketch and label each of the following signal. First one, x of t minus 1 is a given signal. What is t minus 1? Delay the signal by just 1 unit. So instead of starting with minus 2, starts with minus 1. This is x of t minus 1. Next one, x of 2 minus t is given second. I already told 2 minus t, this can be rewritten as x of minus t plus 2. So x of minus t plus 2, first find x of minus t from the given x of t. So this is x of minus t. Minus t, if you are having negative time axis with the plus 2 means delay the signal by 2 unit. Just delay the signal with 2 unit means instead of starting with minus 2, you have to start with plus 0. So this is the second one. Third one, x of 2t plus 1. First we have to find, you are having positive time axis, plus 1 means advance the signal by 1 unit. So advance the signal by 1 unit. The signal gets advanced by 1 unit. And after that, how to find here 2t means, how to find 2t? if you use t equal to t divided by 2 cancel, so divide the time axis by 2. Divide the time axis by 2, it can be written as x of 2t plus 1. Another one more sketch the following signal. First minus 2 u of t minus 1. For that, first we have to know what is by u of t and delay the signal by 1 unit and multiply with minus 2 amplitude scaling. Okay, first draw the u of t, then next one u of t minus 1, that is a time shifting. Delay the signal by 1 unit. After that, amplitude scaling, multiply the signal with minus 2. 1 into 1, here 1 into minus 2, minus 2, it goes on negative side. First one over. Second one, 3 r of t minus 1. How to find, draw 3 r of t minus 1. For that, you have to draw r of t. What is r of t? R of t equal to t for t greater than 0, 0 for t less than 0. Just draw the ramp signal. R of t minus 1, delay the ramp signal by 1 unit. Delay the ramp signal by 1 unit. Instead of starting 0, starting with 1. R of t minus 1. Amplitude scaling, multiply by 3. Multiply by 3. So 1 into 3, 3. Similarly, it goes on. So next one, minus 2 r of t. First draw r of t, multiply with minus 2 for 0, 0, for 1, 1 into minus 2, minus 2. So ramp goes on negative side. The next one, last one, r of minus t plus 2. First, we know that this is r of t. How to find r of minus t? Folding the signal. After folding the signal, r of minus t plus 2, I already told the time axis is negative, plus 2 means delay by 2 units. So just delay by the signal by 2 units. We will be getting the answer. Next one, sketch the waveform represented by the following. Consider that first f1 of t equal to 2 u of t minus 1. First draw u of t, delay the signal by 1 unit, multiply the amplitude axis by 2. This is f1 of t. f2 of t, you have to draw minus 2 u of t minus 2. First find u of t minus this u of t, find u of t minus 2, multiply with minus 2, you will be getting this answer. Third one, you have to find f3 of t equal to f1 of t plus f2 of t. Just add this f1 and f2. So here in the f1 0 to 1 0, here also 0 to 1 0. For 1 to 2 0, for 1 to 2 you are having 1. So here 1, here 0, you will be getting 1. Similarly, if after 2 you are having plus 2, minus 2, cancel each other. So you will be getting, for 1 to 2 alone you will be getting 2 answer. Because here 1 to 2 0, here 1 to 2 plus 2. So you will be getting just only 1 to 2 you are having 1. For all other you are having plus 2, here minus 2, cancel each other. The next one, last one, f4 of t equal to f1 of t minus f2 of t. Minus this just f1 minus f2. So 0 to 1 0, 0 to 1 0. For 1 to 2 you are having plus 2, here 1 to 2 0, you will be getting 1 to 2 value is plus 2. Then after that here 2 to 3 you are having plus 2, 2 to 3 minus of minus you will be getting plus 4. So for all other values you will be getting plus 4.